So today we're solving inequalities, and the good thing is the technique is exactly like solving equations. There's one little difference that you have to be aware of. That's why we're going over this right now. So when you have the addition or subtraction property of inequality, we know that if 3 is less than 5, and if you would add 2 to each of those numbers, you would get 5 is less than 7, which is a true statement. So when we start to solve inequalities, remember whatever we do to one side, we have to do to the other. So we just want to make sure now that when we do that, we have a true statement here since it's an inequality. Same thing with 6 is greater than 2. If I subtracted 1 from both sides, I'd have 5 is greater than 1, and that is true. If I add 3 to both sides of 4 is less than or equal to 7, I end up with 7 is less than or equal to 10. That's true. And if I do greater than or equal to, here 0 is greater than or equal to negative 3, and I subtract 4 from both sides, I'll have negative 4 is greater than or equal to negative 7, which is a true statement because 4 is further to the right on the number line than negative 7. Now when we look at multiplication and division, we have to be careful here. And this is the only thing that will make it different once we get to the negatives. But for the positives, same thing is up there with the multiplication, or I'm sorry, with the addition and subtraction properties of inequality. When I multiply positives on both sides of an inequality, I'll get a true statement because 8 is greater than 6. Multiply both sides by 2, 16 is greater than 12. That's true. If I have negative 10 is less than or equal to 14, and I divide both sides by 2, I end up with negative 5 is less than 7, and that's true. But look at the negatives, okay? And this, I'm glad it's in red because I have a little technique I use to help me remember. But let's go through this. If I have 3 is greater than or equal to negative 2, and if I need to multiply both sides of an equation by negative 3, or any negative number, look what happens. It changes the sign, and I get negative 3 times 3 is negative 9. And over here, negative 3 times that negative 2 is positive 6. Now, look at our inequality. If I just brought that greater than sign down, it would be not true because negative 9 is not greater than 6. It's less than or equal to. So we have to flip the sign whenever we multiply both sides by a negative, or we'll have an untrue statement because it's not true that negative 9 is greater than or equal to 6. It's less than or equal to 6. Same thing, when I divide by a negative, it's going to change the sign, so we have to flip the symbol. So negative 9 is less than 18, but when I divide both sides by negative 9, I get positive 1, and I get a negative 2, and positive 1 is greater than negative 2. So I have to flip that symbol. And I'm going to use, whenever we multiply or divide both sides by this negative number, and it's an inequality, I'm going to say, wah, 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 warning, warning. Or I like to use the sound like a fire alarm, but this morning my voice just isn't ready for it. Okay, so here when solving inequalities, solve like they are equations, except there is more than one solution. Okay, so we have to realize, and we'll see that, and we have to graph those solutions. And then when multiplying or dividing by a negative number on both sides, you must reverse the symbol. So let's do some examples here. So first example, we've got 2x, 2 times x is greater than or equal to 14. So we want to know all the x's that we can substitute in for this x and multiply it by 2, and it will be greater than or equal to 14. So the technique's just like an equation. So I'm going to draw a line here, and the do is multiplying by 2, and so we're going to divide by 2. There's not a two-step, so this is a one-step equation. So when I divide by 2, it's positive, so I don't need to worry about flipping the symbol. So 2 divided by 2 is 1x, or x alone. Bring down my greater than or equal to symbol, since I'm not dividing or multiplying by a negative. And then 14 divided by 2 is 7. So if I come over here and let's just go about, let's see, 1, 2, 7. Let's move it back a couple here. So let's put 7 here, 8, 9, 10, 6, 5, 4, 3, 2, 1. And we want all x is greater than or equal to 7. So we're going to put a closed dot on 7 because it could be equal to, and we're going to shade everything to the right. Now to check this, you could take it, just pick a number out of here and see, does it make it greater than or equal to? I would also pick the number that makes it equal to. So if I substitute in 7, 7 times 2, I get 14, which yes, that is greater than or equal to 14, happens to be equal. If I pick, let's pick 9. So if I do 2 times 9, is that greater than or equal to 14? 18, yep, it's greater than or equal to 14, so they both check. All right, so then let's do the next equation. We're going to, the do is multiplying by -2. So we're going to divide both sides by -2. Warning, warning, flip the symbol. As soon as you divide, change that to less than or equal to, because it's going to change the signs. So here we'll get 1x, or x alone, and over here we're going to get -7. So this time the solutions should be all numbers less than or equal to -7. So how about we go -7, -6, -5, -4, let's go -8, -9, -10. We went less than or equal to -7, so it's a closed circle, and everything to the left. Okay, so if you don't believe me, I'm flipping the symbol. Look now. All right, so could it be equal? Well, let's put in -7. So -2 times -7. Is that less than or equal to, no, wait a minute, I'm going back to the original equation, my bad. Greater than or equal to 14. Well, it's equal. So, yep, that one checks. And then the next one, I'm going to pick, let's do -10. That's easy. So I'm going to do -2 times -10 and make sure I shaded the right side. Is that greater than or equal to, I forgot my question marks here. Is that greater than or equal to 14? -2 times -10 is +20. So, yep, it checks. All right, so let's go down one more. You can do your practice. Okay, so on this one, oh no, there's 2 more, my bad. So we're multiplying by -3. So down here we're going to divide by -3. You might want to put a little star there so you know you're dividing by a negative. And then we're subtracting 15. I made that adding the opposite, adding -15, which is the same thing. But we have to add 15 up here, because remember when we add 15 here, we want a 0. And -3x plus 0 is -3x. But we have to add 15 over here, so we get 18. So now we have not divided by that negative yet, so it's 18 is greater than -3. Now we're dividing by that negative. So I got to flip the symbol. So 18 divided by -3 is -6. And -3 divided by -3 is 1x. So my solutions are all x's greater than or equal to -6. I'm going to turn it around. Whoops, not equal to, just greater than. Okay, so if you were to graph that, we would be graphing, I'm going to go to, let's see, -6, do some -5, -4, I'm going to do -7 on this side, do an open circle on -6 and everything to the right. So if I check that, if I put in -6, I would have, it shouldn't be true. So we always put in the boundary, so let's check it here. So if I do 3, is that greater than -3 times -6 minus 15? That's going to be 18 minus 15, which is 3. So that is the border. Okay, it's not true, but it is the border. And then 3 greater than, is that greater than or equal to -3 times, how about we use -5? -5, add -15, So that's going to be 15 plus negative 15, which is 0. And 0 is less than 3, so that checks. All right, last one. Okay, now on this one we have to be really careful because remember, we don't want a negative x in our solution alone. We want a positive x. So we can move that negative symbol down to the 3. So we're dividing x by negative 3. And I'm going to go ahead and change that to plus negative 5, less than or equal to 12. So order of operations says we would divide by negative. We're dividing by negative 3. So we multiply by negative 3 on both sides. And then we're going to subtract 5 or add negative 5. So we're going to add 5 to that, the additive inverse. So let's get going. So we're going to add 5. We get 0. We add that to x over negative 3. We left with x over negative 3 on the left. Bring down our less than or equal to symbol. And then we have that 12. Then we're going to multiply both sides by negative 3. So as soon as I do that, I got to flip that symbol. So I'm going to make that greater than or equal to. Negative 3 is canceled. I'm left with x is greater than or equal to negative 36. And if we go back and check, I'm not going to graph it this time, but we'll just put in negative, or no, we'll put in, negative 36 divided by negative 3 minus 5. We know, is that less than or equal to 12? Should be equal. Let's see. So I get 12, wait a minute, 36, negative 36. Wait a minute. I never did. Let me see here. So I add 5. I never added 5 to the side. No wonder. See, that's what the beauty of checking. So this should be 17 here, because I forgot to add 5 to this side. I got so engrossed in making sure I flipped the symbol. So 17 times negative 3 would be negative 51. Let's go scribble that out and put negative 51. Okay, so I got to put negative 51 in here. And when I do that, I get 17. And 17 minus 5 is 12. So that's equal. Then if I pick a number, like if I'm shading, let's see, it's greater than negative 51, so how about we put in 0? Let's make it easy. Okay, so if I put in 0, a number that's greater than negative 51, that'll be 0 divided by negative 3 minus 5. Is that less than or equal to 12? So 0 divided by negative 3 is 0. 0 minus 5 is negative 5. Is negative 5 less than 12? Yep, it is. So we're finished. Alrighty.